So now let's take a look more in depth on some of those process improvement and process management theories and methods that we're going to use. Okay. The first one we're going to talk about is called Six Sigma, right? And Sigma comes from statistics, right? So Sigma means a standard deviation. Okay. Where does it come from? So it came from Motorola. It's based on a lot of total quality management principles and other quality management principles, and it was developed by Motorola. Do you guys know what Motorola is? Probably not. Most of you. So they used to make cell phones in maybe a little bit before you were born. They were a sensation. They were a huge company. They were the Apple of my youth, let's say, when I was your age, because they were the largest manufacturer of cell phones, right? When cell phones were only cell phones, not smartphones, and they had a great product, very good durability, that lasts forever. But technology came and they were not on top of smartphones, so they kind of took a little bit of while to adapt, and then they actually went out. I think maybe they still exist. I don't know. Anyway, Motorola developed Six Sigma, and then GE was the one that actually brought it to US. And there's a top manager called Jack Welch, which it's very important. You kind of can read a lot about him in terms of managerial practice, but he actually brought that and make sure that the Six Sigma became the foundation of GE, and GE is very huge and successful company. They change a little bit, and that's how we're gonna actually learn about it. And the incentive to use that was the billions of dollars that GE actually saved by using this methodology. Okay, and they kind of advertise a lot and talked a lot about that, how the companies start using more and more. So it's about solving problems. So it's a methodology to solve problems. You have a lot of tools and metrics to improve and solve problems, meaning improve the process. So it's customer focus. You need involving people. It's process oriented, and in other things that we're gonna talk about. There's a framework of how to solve a problem, and uh, uh, it's strongly based on statistics. So it's used a lot of statistical methods and tools to solve problems, and that's why it was developed with quality problems. But actually, people realized that the same methodology could be used to improve any performance metric, not only improve quality, right? But these methods were very, very useful and practical and easy to implement in quality environments. And then we go to other processes, it has a little bit more difficult, but then was adapted and other methods were developed and kind of brought this all packaged together to help companies solve problems. Okay, if you Google Six Sigma, you got a million hits, and also it. I put that into LinkedIn, for example, put Six Sigma and try to find, and you find 10,000 different jobs that have Six Sigma in their names, right? So it's very widely used and focused basically with a lot of statistics of solve problems. So the goal is to limit variability. So remember that on our process map there, one of the keys were variability. So the key of Six Sigma is to reduce that variability. Okay, and we're gonna look how that looks like. Okay, so to get into an improvement, to achieve a certain improvement, right? So here we have what you call the DMAIC, and that's the process steps that we're going to follow: define, measure, analyze, improve, and control. So memorize that. That'll be very important to the whole semester, and that's actually the framework that we use to solve problems with our Capstone Consultant project. So I talked to you guys a little bit on the introduction about the Capstone Consultant project that we do with our partner firms. We use the DMAIC as our framework. So we go through all those steps, and we're going to go through this class, right? So it's a methodology that you want to optimize the defects or reduce the most defects by looking at our input factors, how that impact on our outcome. So we're going to talk a lot about that, X and Y variables, and I'm not going to go into in depth now. Okay. So what does Six Sigma means, right? If you think about statistically, right? So remember this, right? What is this? The bell-shaped curve. We're going to look, so heads up, there's a lot of statistics in this course. I told you in the first video, right? First video is about this class. So we're going to go a lot of statistics, and I know that you guys are very excited about that. You guys love statistics. That's why you're here. So we have here a normal distribution, and this normal distribution have a mean. And let's say that my specification limit, so the customer wants the product between 35 and 65. We collected a sample of data. We built a histogram. So we have a frequency here. And this frequency is, mean center, and it's about 3 sigma to one side and to another side until you get to the upper and lower specification limits. And we're going to talk more about that, but just kind of a way to explain some of the concepts. I have another process that have the same upper and lower specification limit. I collected data about, but the distribution looks like that. And that's what we call the Six Sigma process. And what's the difference between those processes is the amount of defects that they generate. So if the distribution is wide with the same specification limits, I'll have a lot more data points that go outside those limits, right, in my sample, because variation will occur. If my variation is very, very small, I'll have very little data points, very little observations that go outside the limits, right? And that means that I'm going to have very little level of defects, and very little variation, very little level of defects will reduce the cost and all the problems that will occur in my process. So that is kind of a very basic way to understand what Six Sigma means. It means that I reduce variation, so the data points outside the upper and lower control limits will be very low. So a Six Sigma process will be a lot better process in terms of quality, cost, and distribution, and productivity, and all kind of different performance metrics, because they're not felt the impact of those variations. So that's kind of a way to understand Six Sigma. Finally, we have here what we call the roadmap, just to understand kind of the logic of Six Sigma. And we kind of do an analogy with the funnel. Okay, so basically, you're going an improvement project or a problem solving is about understanding the root causes of something. Okay, so you have to improve something. It's like you're investigating a murder or something, right? So, but it's a little bit different, right? You have the performance metric, right, which is the murder, and you're going to take a look and see who are all the people that could have done that crime. Maybe I should choose a softer crime, but let's say that I have 10, 15, 100 people that could have done that technically, and then I need to find out which one is the one with the highest percentage of chances of actually impact on that performance metric. So a little bit different than murder. I don't need to be sure that it's one person. I need to know the likelihood of these people and find out the ones with the highest likelihood and actually solve the problems by changing, tweaking something on those inputs variables, right? So that's what this is showing. So I have a Y variable, which is the performance metric. So write that down. This is very important. Y is the performance metric. Y is the goal of the problem solving. And I have hundreds and hundreds of different inputs and different things that I do in my company. And what I'm going to do is I'm going to use process maps and FMEAs and fishbones and all kind of tools that we're going to learn about to actually funnel to find out what are the few metrics that actually have a higher probability of impacting on my Y. What are the ones that are more important now? And that's the funnel, because I have 100, maybe you funnel down to 10, and then at the end you funnel down to the vital few that will be very important. And those are the ones that you should change and tweak, and could be the layout, how do I distribute my work, or how do I put my orders, or even my supplier, or how do I measure quality in a supplier. Whatever metric you're looking at could be different things that impact them. So I need to find out those very few vital things that are important to impact my performance metric.